So using complex and irrational conjugate pairs. So we know that if a plus bi is a root of a polynomial with rational coefficients, then a minus bi, its complex conjugate, is also a root. So we can use that fact to write this polynomial function in standard form with roots of x equals 1 and x equals 1 plus I. So the first goal is we need to write the quadratic that is going to have roots of x equals 1 plus I and 1 minus I. And a way we can do that is, let's sort of pretend that we already successfully solved it. So we got x equals 1 plus or minus I. And if we subtract 1 from both sides, we get x minus 1 equals plus or minus I. And then if we square both sides, and then notice if we square the plus or minus, it just turns into plus. So then we'd have x squared minus 2x plus 1 equals, and we know I squared is negative 1. Oh, that's a plus 1, sorry. And then we can add 1 to both sides, and we get x squared minus 2x plus 2. So now this is the quadratic function that will have roots of x equals 1 plus or minus I. So now that we have this quadratic function, we're going to use long division because we know this has 2 of the factors of our original function. And then we're just going to, sorry, I was skipping ahead to a later problem. So now we just need to multiply that by x minus 1, which has the same factor, which is our last root, right? So this one. So and then we can just distribute here. So we do this and get x cubed minus x squared minus 2x squared plus 2x plus 2x minus 2, and combining like terms gives us x cubed minus 3x squared plus 4x minus 2. And that is the function that has roots of x equals 1 and x equals 1 plus or minus I. So, on to the second example. So we're going to do the same thing. The first step here, though, is we need to find a quadratic that has roots of 2 plus or minus I, and then because we know it has the same 2 roots as this quartic function, then we're going to divide those out using long division. So first is, let's create our quadratic that has roots of 2 plus or minus I. So then we would get x minus 2 equals plus or minus I. And squaring both sides gives us x squared minus 4x plus 4 equals negative 1, and then add 1, and we get x squared minus 4x plus 5. By the way, I do need to give a shout out to Ella Garcia for, I was using a different method than this one, and I think this is a way easier way to find the quadratic. So, thanks, Ella. All right, now, long division. So we know that this quadratic that we just made is going to have roots of plus or 2 plus or minus I. So if we long divide into this quartic function that we're trying to find all the roots of, we should get a remainder of 0 and be able to find the last 2 roots that we need. So first, x squared goes into x to the 4th, x squared times, and we get x to the fourth minus 4x cubed and plus 5x squared. And then we subtract, and that gives us, so both of these go to 0, that's 0, and then 6x squared minus 5x squared is 1x squared. Those just went to 0. So now x squared times 1, so a plus 1, and so x squared plus 1 gives us, so when we multiply it by positive 1, we get the same thing, actually, minus 4x plus, everything drops down, and then we multiply by 1, and we get x squared minus 4x plus 5, and subtract, and it all goes to 0. So we got our remainder 0, and then we were left with x squared plus 1. So now we just have to solve x squared plus 1 equals 0, which is going to give us x equals plus or minus I. So our four roots were plus or minus I, and then we started with x equals 2 plus or minus I. Okay, so then this last example, same idea, except now instead of given a complex root, we're given an irrational root, but we can use exactly the same process. So we got 3 minus root 2, which also means that 3 plus root 2 is a root. So we have 3 plus or minus root 2. And subtracting 3 gives us x minus 3 equals plus or minus square root 2. And then squaring both sides gives us x squared minus 6x plus 9 equals 2. And then subtracting 2 gives us x squared minus 6x plus 7. So this quadratic has roots of 3 plus or minus root 2. So if we divide our cubic that we're trying to find the roots of by that quadratic, 31 and plus, so if we divide this by x squared minus 6x plus 7, we should get a remainder of 0, and then we'll be able to solve the remaining function. So x squared goes into x cubed a total of x times, and we're left with x cubed minus 6x squared plus 7x. Then we subtract, and we get that cancels out, goes to 0, and negative 10 minus negative 6x squared is going to be negative 4x squared. 31 minus 7 is 20-something, 24. So plus 24x, and then the 28 just drops down. And then x squared goes into negative 4x squared, a total of negative 4 times, and we get the same thing. And 7 times negative 4 is negative 28, and we're subtracting all of that, so it goes to 0. We got our remainder 0. We're happy. And now we just have to solve. So we got x minus 4 as our answer. So x minus 4 equals 0 is the only thing we have left to solve, and that gives us x equals 4. So these were our 3 roots. 3 plus or minus square root 2.